Okay, let's go ahead and take a look at our practice today. So we are working on the Pythagorean theorem converse. As we work on the worksheet, if you find that you can pause the video and try to figure out the answers on your own first, then come back to the video to check, that would be a good step forward to being ready for the quiz. So let's go ahead and start with our first question. What is a converse? And we talked about this when we made our notebook page. The converse of a statement switches the order of the if and then in the statement. Try to write the converse of the following statements. So if the statement says, if a triangle has 3 equal sides, then it is equilateral. To make a converse statement, we're going to take the if statement and switch it with the then statement. So go ahead and try to write that on your own. To write the converse, we would have written if the triangle is equilateral, then the triangle has 3 equal sides. See how we switched the first statement with the second statement. Let's try a second one. If a number is even, then it is divisible by 2. Take your statements and switch them. See if you can write it first. If a number is divisible by 2, then it is even. So now we're going to take this idea of a converse and apply it to Pythagorean theorem. We know so far that if a triangle is a right angle, then a squared plus b squared equals c squared. Using the reasoning from above, write the converse of the Pythagorean theorem below. So just like we practiced in our notebook, if a squared plus b squared equals c squared, then we know the triangle is a right triangle. The converse can help us prove whether or not triangles are right triangles. So let's go ahead and get started with our practice problems. Again, see what you can figure out on your own and then come back to the video when you need help. Use the Pythagorean converse to prove whether or not the following triangles are right triangles. Be sure to justify your answers. That means we need to show our work. Okay, so taking a look at triangle number 1. Again, we don't know if this is a right triangle, so what we have to do is figure out if Pythagorean theorem works. So I notice that I have 84, 13, and 85. 85 is the largest number. It is the longest side, so if this is a right triangle, then this would be our hypotenuse. If this is our hypotenuse, then here are our legs, A and B. Now we need to test Pythagorean theorem and see if it works. So I'm going to write a squared plus b squared equals c squared. My a squared is 13 squared. My b squared is 84 squared. And my c squared is 85 squared. Now I know that 13 squared is 169. 84 squared is 7,056. And 85 squared is 7,225. If I add 169 to 7,056, I actually do get 7,225, which is equal to 7,225. This is a right triangle. So let's go ahead and take a look at number 2. Notice in number 2, we have 15, 12, and 21. Since this is our largest number, then this would be the hypotenuse if it is a right triangle. So that's what I'm going to count. And then B would be a leg, and A would be a leg. So let's go ahead and write our values in. A squared plus B squared equals C squared. We're going to check and see if this works. 15 squared plus 12 squared equals 21 squared. Now 15 squared is 225, plus 12 squared is 144, and 21 squared is 441. 225 plus 144 equals 369, which is not equal to 441. They are not equal, so this is not a right triangle. Since Pythagorean theorem does not work, this is not a right triangle. So let's go ahead and try number 3. Again, if you feel comfortable, pause the video, try them on your own, and then come back and check your work. In number 3, I have 30, 15, and 45. The 45 is the larger number, so this would be my hypotenuse if it's a right triangle. That would make 15 a leg and 30 a leg. Now that I've labeled my 3 sides, I can write my formula. A squared plus B squared equals C squared. A squared is 15 squared. B squared is now 30 squared. And C squared is now 45 squared. 15 squared becomes 225. 30 times 30 is 900. And 45 squared is 2,025. Well, I can tell already that that's not going to be 2,000, but 225 plus 900 is 1,125, and that is not equal to 2,025. So this is not a right triangle. And let's take a look at number 4. Number 4, I have 18, 24, and 30. Since 30 is the largest number, that would be the C if it's a right triangle. That means the 24 would be a leg, and 18 would also be a leg. Oops, I need to make that an A. There we go. Okay, so now we have A squared plus B squared equals C squared. A squared becomes 18 squared. B squared becomes 24 squared. And C squared becomes 30 squared. Now 18 squared is 324. Plus 24 times 24 is 576. And 30 times 30 is 900. So if I take 324 and I add it to 576, I actually do get 900, which is equal to 900. So this is a right triangle. And since this is a right triangle, let's go ahead and put in our right triangle. There we go. Right triangle. Okay, let's go ahead and turn the paper over. Now this setup looks a little bit different, but we're going to continue with the same type of work. We're going to have 3 sides, and we're going to test to see if it makes a right triangle. Determine if the following side lengths would form right triangles, and show your work as proof. Okay, so we have side lengths of 12, 24, and 36. So taking a look at that, I noticed that the 36 is the largest of the 3, so this would be my C. That means that the 12 and the 24 are the legs, and it doesn't matter which one's which. We'll just make 1A and 1B. So now they want our proof. So if we know that A squared plus B squared equals C squared, my A squared is 12 squared plus B squared now is 24 squared, and C squared becomes 36 squared. 12 squared is 144. 24 times 24 is 576. And 36 squared is 1,296. Now when I add 144 and 576, I get 720, which is not equal to 1,296. So no, this is not a right triangle. Let's go ahead and take a look at the second one. I have 16, 9, and 11. Since 16 is the largest of the sides, that would be the C if it's a right triangle. So then I can go ahead and name these A and B because those are the legs. So now we have A squared plus B squared equals C squared. We have 9 squared plus 11 squared equals 16 squared. 9 squared is 81 plus 11 squared is 121. And 16 squared is 256. Now 81 plus 121 is 202, which is not equal to 256. So no, this is not a right triangle. If we take a look at our next one, we have 20, 29, and 21. 29 is the largest, so that's our C. And then I'm going to label A and B. Remember, we can, because of commutative property, switch those two around. A squared plus B squared equals C squared. A squared is 20 squared plus B squared is 21 squared, and C squared is 29 squared. 20 squared is 400. 21 times 21 is 441. And 29 times 29 is 841. And I can see right here that 400 plus 441 is 841, which is equal to C, which is 841. It works. So this is a right triangle. And our last one gets a little tricky because of decimals, but we're still going to plug through. If we take a look at, we've got 12.5, 7.5, and 10. 12.5 is the largest of the three, so that is going to be my C. Then I'm going to label the other twos A and B. So let's go ahead and start. A squared plus B squared equals C squared. A squared is 7.5 squared, plus B is 10 squared, and C squared is 12.5 squared. 7.5 times 7.5 is 56.25, plus 10 times 10 is 100, equals 12.5 times 12.5 is 156.25. So if I take my 56.25 and add it to 100, I actually do get 156.25, which is equal to C squared of 156.25. It checks, and yes, these three sides make a right triangle. Okay, now for the word problems. I challenge you on this one to go ahead and read the word problem first, and then try to draw it. And then go ahead and check the video and see if you've drawn your picture correctly. Then we'll go ahead and solve. Use the Pythagorean converse to help you answer the following. Jimmy thinks a window frame in his house looks slanted because the corner doesn't appear to be a 90-degree angle. His wife thinks it looks just fine. They measured the window to check and found the width to be 25 inches, the height to be 36 inches, and the diagonal distance to be 45 inches. Who is correct? Okay, so they have a window. And they're not sure if it is a right triangle or a right, if the angle here is a 90-degree angle. So they do know a little bit of information here. They know that, let's see, the width of the window is 25 inches. So this is 25 right here. From here to here, the width of the window is 25 inches. The height of the window from here to here is 36 inches. And the diagonal distance, diagonal, meaning going from one corner to the other corner, is 45 inches. So we have our three measurements, and now we need to figure out, is this a right triangle? Well, since the 45 is the longest side, that is our C. And so I'm going to name that B, and we'll name this one A. So let's go ahead and check. We've got A squared plus B squared equals C squared. 25 squared becomes our A squared. B is 36, so now we have 36 squared. And C is 45, so that's 45 squared. Now, 25 squared is 625. 36 squared is 1,296. And 45 squared is 2,025. Now, if I take these two numbers and add them, I get 1,921, which is not equal to 2,025. So in this case, they wanted to know who is correct. So Jimmy said it was slanted, and his wife thought it looked just fine. So that means that Jimmy is correct because it is slanted. It's not 90 degrees. Okay, let's go ahead and look at number 7. Again, take a moment to read it and see if you can draw your picture first, and then come back and check your work. Patty wants a triangular garden in her backyard for all of her vegetables. She is going to use 3 pieces of fencing that measure 7 feet, 10 feet, and 8 feet. Will her garden be in the shape of a right triangle? Why or why not? So she's got 3 pieces of fencing. So let's draw 3 pieces. She's got a piece of fencing, a piece of fencing, and a piece of fencing. She's got 3 sides. Now the longest side is 10. So I'm going to name that C. One of the legs is 7, that B, and the other one is 8. We'll name that one A. That's an A. Okay, so if this is a right triangle, then this should fit our Pythagorean theorem. Let's do A squared plus B squared equals C squared. A is 8 squared, B is 7, becomes 7 squared, and C is 10, so it's 10 squared. 8 times 8 is 64, plus 49 equals 10 times 10 is 100. And if I add those together, I notice that 64 plus 49 is 113, which is not equal to 100. So no, this is not a right triangle. Her garden will not be in the shape of a right triangle because the sum of the 2 legs do not equal the sum of the square of the hypotenuse. Okay. So no, it's not a right triangle. Okay, and in number 8, now this one is tricky, so we'll go through this one very slowly. The perimeters of 3 squares are shown below. Perimeters. Now I want you to remember what perimeters are. Perimeter is the distance around the shape. So if I were to start at this corner and walk around the outside of this square, I would walk 48 feet. If this is 140 feet, I would start here and it would take me 140 feet to go all the way around the square. And in this square, it would take me 148 feet to go all the way around the square. So that means I don't know side lengths yet, but I do know how long it takes to go around the square. Now, since these are squares, there's something important that we know. We know that all 4 sides are congruent. All 4 sides are the same. So if this perimeter is 48 feet, then that means I can take 48 and divide by 4 because there are 1, 2, 3, 4 sides. If I take 4 and divide into 48, 4 goes into 4 one time. Bring down my 8. 4 goes into 8 2 times. 2 times 4 is 8. So the side length of this square is 12. Okay. The reason I'm doing this, I forgot we probably should read the rest of the problem. It says, could the three squares be positioned so that they meet to form a right triangle? So can I move these around so that they look like a right triangle on the inside? So they want us to take the small square and then take the medium square and then lay along the hypotenuse side, the long square, or the bigger square, and see if this would truly be a triangle on the inside. Would this be a right triangle? This shape right here. Okay. Remember, this is the one that's 48. This is the one that's 140. And this one's the one that's 148. So they want us to take these three squares and position it so we get a right triangle in the middle. So now we've decided, I got a little ahead of myself, this one has a side length of 12. So we know that this leg right here is 12. Now we need to figure out what this leg is. And then we need to figure out what the hypotenuse is. So if I have 140, I'm going to take 140. Now remember, that's the distance around all four sides. So if I wanted to find out just one side, I would divide by 4. 4 goes into 14 3 times. Down my 0. 4 goes into 25 times. And so the side length is 35. So my side length here of my 140 foot perimeter square is 35. And for my perimeter of 148 feet, that would be 148 divided by 1, 2, 3, 4 sides. Again, goes in 3 times. 4 goes into 28 7 times. 7 times 4, 28. So that means that my hypotenuse is 37. So if this is a right triangle, if we can position all of these squares to make a right triangle, then this should fit Pythagorean theorem. So let's go ahead and look at a squared plus b squared equals c squared. A squared is a, there we go, is 12, b, c. So a is 12 squared plus b is 35 squared, and c squared becomes 37 squared. Now 12 squared is 144. 35 squared is 1,225. And 37 squared is 1,369. Now if I add these two numbers together, then I do get 1,369, which is equal to 1,369. So this is going to make a right triangle. A right triangle. A right triangle can be made. Okay, that was a tough worksheet. Now that we've done this one together, there is one for you to try on your own. Good luck.